Awesome. So I wanted to touch upon, we heard about agents the whole day, right? And you saw the cool demo that AOT did, right, on the water permit use case, right? And then also we saw about the freedom of information use case and all of that, right? I know within the demo, it sounds all super easy, right? Like, hey, this looks awesome, actually. All it takes is probably a few clicks to reach the stage where I'm starting to see all of this happen. But what I want to speak to is behind the scenes, what does it actually take for you to build an agent and get it to a stage where it's production ready, right? Like, okay, sure, I release this agent. How confident am I that I won't be in the press tomorrow for an inadvertent response that it gives, right? How do I make sure that I'm able to keep track of how these agents are behaving, right? And even in case something goes sideways, what are my options to mitigate, manage it, right? So think about the broader context around, sure, what does the platform offer in terms of like running agents, building agents, all of that, right? So I wanted to speak a bit more on that. I'm going to skip a lot of these slides because I know in the interest of time and also lunch, right? What exactly is an agent, right? Like let's break it down into the nuts and bolts of what an agent is, right? An agent in short is a large language model, right? Could be GPT or Claude, Anthropic models, whatever the case is, right? The instructions, the prompts that go with it. We heard about MCP during, I would say probably, if we keep a counter, maybe 10 or 15 times a day, right? The tools, right, that allow the agents to perform these actions. And then, of course, right, like we look at memory as well, right? So these are the, let's say, the building blocks that go behind that go behind creating an agent, right? But I summarized it in quite a short way, right? Like when I say memory, what does memory actually mean? Memory refers to the fact that you have the, let's say, data sources accessible to the agent for it to make meaningful sense of your enterprise data, right? So we heard Rob speak about Jailbreaks and the platform and the capabilities that it offers, right? But it goes beyond that as well. It could be unstructured data, even just simple policy documents that we saw in the water permit use case, or could be structured data too, right? That could be in your Oracle tables and whatnot. How do you get it to a point where you're able to surface up that data so that AI can reason on? That's where most of the time goes behind when it comes to building agents, right? What we refer to as the plumbing it takes for you to get your first meaningful output, right? And how do we reduce those cycles, right? What does the platform offer in terms of Microsoft and Azure? How do I reduce that pretty much? Awesome. So breaking it down, right, to what I said. So you have the, let's say, the agent orchestration, right? The brainchild behind, like, sure, if I get a certain amount of input, what actions should I do? Should I actually call this API? Should I actually hand it off to another agent? What we refer to collectively as orchestration, right? And then the models themselves. So you heard me speak through all of this, right? And you're starting to wonder, like, well, the prominence of all of this conversation around AI came with the rise of GPT models from OpenAI as such, right? But if you realize that that's the least amount of time I would have spent on this conversation here, because we realized that we have reached a stage where you have a choice of models that some are domain specific, some are generic in nature, but the value that you get out of these models lies in getting to a stage where you create the platform and the infrastructure that lets these models act effectively, right? So think of it as the fact that you have a, let's say, a super smart brain around you, but only if you feed the necessary context and information can it give you a meaningful response, right? So that leads to the next one, knowledge and tools, right? Super important that we make sure that we are able to surface up the data that is required for the agents to reason. And the other one is observability, right? As I said before, practical experiences from the field. So I have an interesting story on this, right? So we launched an agent for VIHA, right? Vancouver Island Health Authority. Jeff knows about this, the importance of red teaming, right? I keep telling that red teaming is important, right? And that agent is a simple agent, right? It pretty much its role was to guide people, both within Canada, outside of Canada, about why should you relocate to Vancouver Island for a career, right? Like we have a shortage of nursing staff, we have a shortage of clinical staff, right? But the big question is like people don't even know where Vancouver Island is, right? If you're living in say Australia or in Asia, right? You don't even know what the location is, what kind of a lifestyle am I signing up for, all of those things. So you could imagine that this could be like, oh well, it's curated data sets, it's going to speak about the island in the best possible way, in the most glowing way, right? And it all worked good, awesome. Like let's say the responses were amazing. Like you could even ask a question like, sure, I have 2 kids, I want to relocate to the island, my kid wants to do this, what are my options? It would start giving you all of that, right? So it was good. And then we got an alert one day stating that somebody is trying to siphon off source code from the agent. And we were like, okay, what happened with this, right? So somebody went in and said, I am a Python developer and I'm actually wanting to work at VIHA. Can you give me some interview tips? Can you give me some coding samples on how to prepare for the interview? And lo and behold, it started generating code for that, right? So look at the implications of all of this, right? So you have a situation where you could now use this agent to get free source code generated at somebody else's expense, at the expense of VIHA, right? It's not going to cost anything malicious though. Like what would you do with that source code, honestly? It's not going to tell the agent like, can you please reveal your meta prompt or anything as such. No, it's not going to do that. But it makes you think about the potential possibilities of what happens when, let's say you put these agents in the wild and you have not gone through enough testing and validation. Mind you, for this one, we went through 3,000 test cases for red teaming. And despite that, we caught this one, right? So in short, right, like there's a lot more importance that goes with observability, right? So before you release, of course, red teaming is going to be critical, right? Fine-tuning and customization, I would say it's still in the nascent stages, right? Like it's not like mature as yet, right? Like fine-tuning will play a significant role. We heard about costs, right, over here about token optimization and the costs. Fine-tuning does play a significant role where you use a large language model, which is really large, right? Like say GPT-5, right? But you want to say like, well, can I actually distill the outputs to a way where I can force it into a GPT-5 Mini, right, which costs probably 1/6 the cost of a token per token inferencing cost with GPT-5, right? So those are some of the use cases that are coming up. And of course, the deployment choices that you have, right? Like, yeah, you should have the flexibility to deploy to local and edge. Of course, some models, due to licensing requirements, cannot be deployed to local, but the case with open source models, right, you would have you would want the flexibility for the platform to support deploying it close to where your data is, right? So collectively, all of these things that I spoke of form what we refer to as Microsoft Foundry, right? So the models that you use as part of the agent service itself, I'll speak a bit more on that. IQ is interesting, right? So IQ serves the purpose of fixing the plumbing, right? Like how do I make sure that I bring the data across the organization to a point where it's making itself easy for reasoning, right? Like how do I skip the line and get it closer to the model itself? Tools, MCP, we heard it throughout the day. What we do is that, like, as you might know, within the Azure platform, there are a lot of solutions, right? Like specifically for workflow automation and all of that. We have built a lot of connectors over the time, right? Like we have more than 1,000 plus connectors. We are converting all those connectors into MCP compatible endpoints itself, right? So if you want to connect to an Oracle database and you're wondering like, is there an MCP tool that lets me connect to an Oracle database? The answer is yes. Same thing goes for SQL, all of that, right? So we are in the mission of converting all of the standard connectors that Microsoft already has into MCP compatible endpoints. And of course, to Rob's point, he was spot on, right? Like, hey, I know that the Gen AI models seem cool and fascinating, but traditional machine learning has a very active role to play. And more, we are starting to see some interesting use cases as well, right? Like where machine learning, so let's say we are building a model that is predicting a certain variable or a parameter, right? We are starting to see where the machine learning model itself starts becoming a tool for the agents to work with, right? So, for example, if it wants to predict the price given a certain set of conditions, it's going to call this endpoint, get the results, and then do further reasoning on top of that, right? So we're starting to get into these types of patterns. And of course, you get the control plane with Foundry that, as I said before, right? Like how do you make sure that you're operating this in a safe environment? Now, I intentionally put this slide through here, right? Because I wanted to make you understand on like what it actually really takes to operationalize an AI solution. So when Jeff spoke about when Jeff and Abin did the demo on the water permit agent use case, this was what happened behind the scenes. All of this happens behind the scenes, right? The logging, the evaluations, critical steps, right? And then of course the choice of models, right? The agent knowledge. So you realize that before the let's say the agent gives its output, right? Like the amount of things that we have to do is quite significant actually. Now, in terms of Foundry, right? Like I am going to switch gears into showing what does Foundry offer besides the platform and the tools and the capabilities, right? Like here's a let's say a code snippet, right? And I'm not going to go much into the depth of it, but if you see the code snippet, right? And why I have this here is to show how easy it is for you to build your own conversational agent, right? It took probably this is probably less than, I would say, 50 lines of code, right? So if you see the steps, all it says is that like create a knowledge source, reduce a knowledge source. You create an agent, you provide the large language model. In this case, it uses GPT-4o, and then you pretty much create what is known as a thread. A thread is conversation, right? Like it's important to have the context of the various conversations that you have with AI so that it can give meaningful responses the next time you reach that endpoint, right? And then you pretty much say like, okay, here is what it is. Now start serving me some requests, and that's it. Like we look at these 5 to 6 calls. All the, let's say, the complicated stuff that I showed you in the previous slide gets encapsulated in these 6 API calls that you're seeing right here, right? So the other interesting part is that even though it says GPT-4o, technically you can swap this out with the Llama model as such, and this code will work as it is. There'll be no challenges with it, right? So what Foundry does is that it starts creating an abstraction irrespective of the models that you use, irrespective of the data sources that you use, right? So you say like, listen, my data source is an Oracle. Okay, it does not matter. The model I want to use is an open source model. Sure, that doesn't matter. The way that you're going to construct the agent is still going to be consistent, right? So that's important, right? It makes your life a lot easier, because the case be that you have a higher reasoning model that comes out tomorrow, the amount of change for you it takes is quite limited. But that does open another problem as well. Like let's say I swap one model to another model. How do I do, let's say, regression testing that I did traditionally in traditional DevOps in the AI world? Like what does regression testing even look like for me in such a situation, right? I'll cover that a bit later. Awesome. So in short, right, like the Foundry platform itself, right? As I showed before, it's super easy to create using that particular SDK, right? And then we have the shared services layer, which is based on the OpenAI extensions, right? Like pretty much we built on top of like the OpenAI APIs, and we're making it like common. So you don't need to worry about what's the API layer for Llama or what's the API layer for Cohere. You just say, just do the reasoning for me. I'll handle the details for you behind the scenes. Now again, this is probably a slide that I'm not going to go much in depth with, but what's important here is that when you look at the ecosystem of Microsoft solutions, right, like you're probably looking at in your organization using Microsoft 365 Copilot, right? How do all of these pieces fit together, right? Like sure, if I'm creating an agent that is released in Microsoft Foundry as the platform, the use case, in this case, of course, is a conversational agent that supports water permit, but it could be something else, right? I like the fact that you're able to retrieve policy information, right? How do I make sure that I bring this policy retrieval agent into, say, Microsoft 365 Copilot, right? So we looked at it quite seamlessly. Of course, we follow the open standards, right? Like MCP, A2A, all of that. So pretty much the integration for you is like out of the box. So for as a developer, right, if you're looking at like, okay, where do I start? What are my options here, right? We also offer a lot of templates. So it's pretty much for you to go in there and say like, hey, I need to create a conversational agent, a few clicks, you have the templates ready and you're off to the races. Awesome. Okay, so within Foundry, we have what is known as the Foundry agent service, right? So we cater to a lot of, let's say, use cases and also scenarios, right, within the Foundry platform. So we have this, let's say, WYSIWYG style editor that lets you build your agents faster, right, without having to go through code, right? This is what you would want to do. Sure, you have this possibility over here, right? And then also you have what is known as the Microsoft Agent Framework. I'll just go here, right? Which is what Abin spoke about briefly before, right? Like, which is our own open source framework that kind of lets you do code first agents, right? The advantage of using a framework, like why would you use a framework, right? Now, once again, right, frameworks have been around for a long time, right? Like if you look at ever since we have, let's say, Gen AI based applications coming out, LangChain was extremely popular, semantic kernel very popular, AutoGen extremely popular as well, right? Microsoft Agent Framework was, let's say, was a culmination of all of these efforts. So the industry started going in two parts, right? One was when we first had Gen AI applications, it was you writing, let's say, plugging in Gen AI into an existing code flow, right? Meaning you wrote a deterministic application where it like very clearly said, okay, if this condition, then do this, all of that. And then you would plug in the call to the generative AI endpoint, and the results would come back, and then still the deterministic flow would happen, right? And then AutoGen came and said, well, we're kind of limiting what we could do with these agents. Why don't the agents reason and decide when to call what, instead of us deterministically moving down with the path, right? And then also it opened the pathway for multi-agent workflows and so on, right? So combining all of this, we felt like, why should we have two frameworks where one supports this and the others? So we kind of combined all of that and we created Microsoft Agent Framework, right? So which makes it easy for you to like adopt the MCP endpoints and then also expose your agents either as compatible with the A2A or themselves as an MCP endpoint as well, right? So, okay, I'm really going through this quickly now, right? But yeah, I'll make sure that I hit on the key points, right? Model router within Foundry, again, it's something that we learned over the past few years with our customers, right? Like we realized that do all, let's say, requests need to go to a large language model? Maybe not, right? Like what if the request is just summarizing a paragraph, right? Like, do I need to use an expensive GPT-5 model? No, maybe not. You can actually offload it to 4.0 Mini or something like that. So model router looks at the prompt, looks at the task that you're trying to accomplish, and then intelligently routes to the model that it feels would be the best for in terms of like performance, cost, all of that, right? So these are all things that are baked into the platform. So behind the scenes, you would no longer say GPT 4.0, you will say like model router, and then let the model router figure out which model is the best to give the response to you. And then of course, right, from an Azure point of view, I know that we spoke about OpenAI, but we do support, we have more than 11,000 models. Mix of like open source models, and then like of course there is Cohere and all the other models as well that are available natively. Okay. The other challenge, right, that we have seen, right, in terms of integration, right, is, as I said before, AI agents are only as good as the data that they reason on, right? So I think we spoke about RAG, right, where the first step is probably going to a data source and retrieving the relevant information. But what if the questions that come in, right, like let's say you're asking a question of like, okay, what is the price of this and in the last year in this particular country, right? Like it's kind of like a lot of, let's say, query parameters packed into one, let's say, question that you're asking, right? So the challenge that we always had previously was that we would send this question directly to the underlying, let's say, vector data store, right? And we would say like, sure, give me the best possible results. And what we would try to do is try to combine all of them together and try to return the results that it felt was the closest to what the user was asking. It never broke it down into 3 separate queries and then did not take the time to assimilate the results and then filter the results as it saw fit, right? So pretty much we were treating this like yet another database, right? And we would not get great results with it. So what switched is that we now moved into what we refer to as Agentic RAG, right? Where we say when the question is sent to the, let's say to Foundry IQ in this case, right? it does not immediately go to the data sources underneath, right? It has a look at the knowledge base that is there. So sure, if this is a policy related question, it knows that this policy information is in this particular data source. Let me construct the query to go to this, right? Sure, if this is a policy related information, but at the same time, there should also be an access to a table, like maybe an Oracle table as such. Let me construct the query as well, right? So in parallel, it starts distributing all the access to the data, and then the results come back. There is also a quality check on the results, and then the results are compiled together, filtered before it is sent back. Like a huge improvement. I believe this alone is making a significant change on the quality of reasoning that AI agents are having right now, right? So this is also part of the platform without you having to configure anything, right? All you have to do is say, that's my knowledge base, and that knowledge base has this information, and you just say, where is the knowledge base located? And pretty much the Agentic RAG subsystem will take care of like connecting all the dots and then compiling the necessary information. As you see here, right, I'm not sure if you're able to see this picture cleanly. Yeah, we support a lot of data sources as part of Agentic RAG, right? Like there is also Databricks there, Fabric, pretty much all of them out of the box for you. All right, so I spoke about the interesting situation, right, with VIHA and the career chatbot that we released for them, right? And the learnings that we had. But we know that this is the reality as such, right? Like we have situations where you have a public-facing conversational agent. There will be malicious actors who would want to see if they can do a jailbreak attempt on that one, right? I mean, when I speak about jailbreak, right, like, or even thinking about like what could be like the security risks working with large language models, right? So remember this. Every time you do, let's say, a knowledge retrieval, right? It could be a Word document, or it could be, let's say, a set of records, whatever it is. You send your prompt. All of that is compiled together for the agent to reason on, saying, okay, I have this information. Here is the user question. Let me start generating the response, right? But what if the data source itself, right? Let's say it's a Word document, is corrupted, where there are instructions to tell the agent to behave maliciously. Right? It's possible. These things have happened actually, right? Then in that case, then the agent is going to instruct or do something that is malicious, right? How do you avoid all of this? How do you control all of this, right? So that's where we focus extensively on the observability side of things, right? Like within the Microsoft Foundry control plane, the moment you start using these large language models, these controls are turned on for you out of the box, right? Like we have all of these security functions that are available, right? And then also the observability layer that speaks about like, is this content safe? Like we have a lot of content filters, right? We want to check if there is any malicious content going both ways, right? Whether the AI is generating anything malicious or the input is also malicious, right? And we have the ability to flag and stop the request before they're even processed by AI, right? So a lot of safety checks before before the request goes to the actual large language models themselves. I'm going to go through this quick because it's a lot of screenshots here, right? Moving on, right? I speak about the fact of like, what does it mean to release solutions that are safe, right? And how do you even do things like regression testing? Like what does regression testing in AI look like, right? So when you look at, let's say, the DevOps piece of actually building and releasing agents, right? We get into the domain of evaluations, right? Where we start measuring, depending on the use case. Once again, a conversational agent could have different set of criteria that is defined as what is qualitative for that, right? Like for a conversational agent, we could say, are the responses fluent? Are the responses coherent? Is it making sense? Is it truthful, right? Whereas for a task-oriented agent, which is running in the background, you would want to check, it was supposed to do task A. Did it actually finish this task, right? So we are now starting to think of different realms of like what evaluations actually look like. And the other one is also deterministic versus probabilistic, right? So functional testing, very deterministic, right? You give 3 parameters A, B, C, you know that it produces output D or E, right? And every time you run the test, it should be doing that. Whereas with large language models, it's going to be very probabilistic, right? Like if you have a large language model that says, give me a greeting, well, today morning it might say good morning. The next day it could say, hello there, how are you, right? Like semantic meaning is still the same, right? That's the point behind this, right? So how do we start switching to thinking about like validating the solutions from a semantic point of view and not necessarily the specific outputs that we want? So if you see here, right, quite a lot of evaluations are there out of the box, right? Like for example, as I spoke to a few of them, there is coherence, fluency. There is also real-time evaluations as well, right? So that's interesting. That the fact that every response post-deployment. So as part of, think of this as part of continuous monitoring, right? You've now deployed your models. It's servicing people in real time, right? How do we keep track that it's still telling let's say it's still giving responses to my own data sets, right? So every response, we know that responsible AI principles state that every time you have an AI response that's generated, you need to provide the data source that it used to actually generate that response, right? But what if the response is not connected to the data source? Like how do you keep track of all of that, right? So we do real-time evaluations as well. Every time there is a request response cycle, we keep track of like, okay, this response was sent out. We have a parallel stream where another AI agent picks it up and checks, is this valid or not, right? And then of course, before release, we have the evaluations, right? Which will also go through all of these checks to make sure that your agents are safe, right? For production release. I'm going through all of this, right? So automated evaluations is what I said before, right? You create your data set, and then you pretty much make them go through all of these tests over here. And then in your DevOps pipeline, right, whether it's GitHub or your tool of choice, you put the gates saying that, okay, it passed A, B, and C, fit to release to production pretty much, right? You also have the option to do manual evaluations as well. Like in a specific case, like you would say that, well, I want to really understand that here is a trace of what went malicious. Let's actually see what the evaluation system is telling me. Maybe I need to tweak my evaluations to avoid this in the future, right? And this is an interesting topic, which I'm a bit on the fence with this, right? You can also use AI to generate test data too, right? Which is helpful in cases where you want to accelerate, right? But again, I would say use it with caution, sincerely, right? Like you want to make sure that you as the human or you as the teams that are eventually going to work on these take the responsibility of generating the test data for the agents too, right? And that's it. I hope I kept my time as quickly as possible. Yes, right? I saved 3 minutes. That's good. Any questions?